Okay, so I will start with a new discussion from today onwards. This is called Scalars and Vectors. Okay, and before going into the whole thing, I want to give a brief layout of all the topics that I will discuss here. So the brief layout is something like this. The first thing that we will discuss is all the definitions of scalars and vectors, and let me give you a little bit of intuition in those things. So intuition and definition. Okay. The next thing we will see is how to geometrically represent a vector. So a vector will be a new quantity that we will deal with, and I want to geometrically represent that. So we will see how that happens of vectors. Okay. The next thing I want to discuss is some of the important types of vectors. So some important types of vectors which will be useful in long run. Okay. The fourth thing that I want to discuss is the addition of vectors. So this is going to be a very important thing, addition of vectors. From here onwards, we will actually start discussing all the algebra of vectors. Okay. And this addition will be done by graphical method. Okay. Later, I will discuss a much more simpler and feasible way, which is the analytical method, but that is for later. After I have discussed the resolution of vectors, the fifth topic that I want to discuss are some of the properties of vector addition. Okay. Some of the properties of vector addition. And with it, I'm also going to discuss the subtraction of vectors. How to subtract two vectors. Okay. So as you can see, addition of vectors, subtraction of vectors. The next thing could be the multiplication. But before that, let me resolve two vectors. And what do I mean by a resolution? I will discuss it in the coming lectures. The resolution of vectors. Okay. And the seventh thing is going to be addition by analytical method. The feasible way. Addition by analytical method. And the last thing is the multiplication of vectors. Multiplication of vectors. This is going to be the most important topic in the whole chapter. But so yes, so this is the brief layout of how I am going to proceed in the whole thing. Okay. So let's start with the number one, the intuition and definition. Intuition building and definition. So what is the meaning of a scalar and what is the meaning of a vector? Let me give you a very simple example through which you will understand what I am talking about. Let's say there is a one-way road, and the one-way road is something like this. Okay, something like this. And there's a car going. Okay, pardon my drawing, please. There's a car going like this, in which there are thieves. Okay, there are thieves, and you are standing here, you're a bystander, and you see that the thieves are going. This is a one-way road, so they are going in this direction. But one thing that you notice, and I don't know how, but you have some kind of gadget that tells you how fast they are moving, how fast they are moving. Okay, you have some kind of gadget, you can say a speedometer or anything like that, and you can tell me how fast they are moving. This information is now available to you. A policeman comes to you after they run. He comes to you and he asks you, have you seen thieves going? And you say, yes, some people were going. Okay. But the next question that he asks is the important one. He asks how fast they were going. Do you have any kind of idea how fast? And then you say, okay, maybe 25 kilometer per hour, or maybe something like 15 kilometers per hour, whatever. But the main point is you give this numbers. Okay, you provide these numbers, and that number is sufficient for him. For the policeman, his question is answered. This number is sufficient. Okay, this number told me what it told me. It answers how fast were they moving. है ना? This question of how fast. Okay, so in elementary standards you have seen that this how fast a particle is moving, or how fast a body is moving, is called the speed of the particle. The speed. Yes, so this is a speed, this is a physical quantity. Okay, and this was case 1. Okay, scenario 1. Scenario, or let's say case 1. Okay, let's consider one more case. And the second case is something like this. Case 2 is something like this. You have a 4-way now, not a 1-way, but a 4-way. And let me make the 4-way first before I talk. Something like this. And then a car again is moving. So it is moving. Okay, and again you are standing here, maybe you're standing here, and you record how fast is he moving. But then also you have one more information, that in which direction will he take the turn. Will he go left or right, or maybe straight forward, right? And let's say for some reason he takes this turn. Okay, this turn. So now you have two information. You have the information of how fast was he moving, how fast was the car moving. So you have this number. You remember? You can only give one number and this question is answered. So you have the number. You have one more quantity, and that quantity is in which way or in which direction. In which direction the car turned. The car turned. Yes, you have this quantity as well, this information as well. So this information tells me in which way, in which way was he moving. So this number plus this information of in which way is he moving gives me two bits of information of this whole process. So now the policeman comes and he asks, in which direction was he moving, do you know? And how fast was he moving, you know? And you can say your answer could be something like this. Maybe this guy was moving, let's say this is north and this is west, this is east, and this thing is south. This is how the directions are. And you can say, okay, this guy was moving with 25 kilometer per hour. So again, you remember, you give the number. So you specify the number plus you say one more thing. And what will that be? He was moving in the east direction. Okay. So this is the next information that you are giving me. In which direction was this guy moving? And from elementary classes, you know that if I say that this number is actually telling me the speed of the particle or the speed of the car, plus if you specify direction, then this quantity is called the velocity of the car. So what is the distinction between velocity and speed? Speed only tells me the number, okay? But the velocity tells me the number plus a direction. This is again a physical quantity. Yes. So now I hope you get the distinction between this. So now what do you say? You say ki broadly in physics there are two kinds of bins. So I have bin 1 and I have bin 2. And there are physical quantities which can be thrown into these bins. Physical quantities can be thrown into these bins broadly. And the bin 1 is actually called the scalars, and bin 2 is called the vectors. Okay. So what is a scalar quantity? A physical quantity which can be described just by providing a number. Just by providing a number is called a scalar quantity. Okay. What is this number telling me, by the way? It tells me how much. So in the above case, it told me how fast was this guy moving. But in general, it tells me how much is that quantity. So if there is speed in a guy or speed in a car, we are considering speed in a car, then how much fast is that thing moving? That is speed. So this number tells me how much. Okay. I will later describe this number by something called to be the magnitude. Okay. And magnitude, I have not described it or I have not defined it formally, so I'm not using the word, but formally you should really write here by providing a magnitude only. Okay. In broad sense, you can understand the magnitude also talks about how much, basically. Okay. How much is there a quantity? So let me give you an example. If you have a grain, a bag of 5 kilogram of rice. Yes, you have this bag and in it there are 5 kg of rice. Then if a person who wants to buy this bag, the first question that he asks, what is the amount of rice that is inside? What is the amount of rice that is inside? And then you give a single number, right? A number is your answer, and that number suffices, and that number will be 5 kilogram. Yes, this number, if you say, it suffices to tell me about the physical quantity that we are considering. And what is that physical quantity? It's the mass of this rice. What is the mass? Yes, so if you tell me this number, then mass of rice is defined. How much mass is there? That is told by this number. So a scalar quantity is what? If it is completely defined by how much, that number if it is told, then you can say I have completely defined the quantity. Then such quantities are called scalar quantities. Yes, let me go to the second bin. The second bin, as you can imagine, these are physical quantities. A physical quantity which needs both. It needs two things. It needs a number plus a direction. If you don't tell me both of the things, then the physical quantity is not completely defined. So it needs both for complete specification. For complete description. Let me say description. If you don't tell me both the things, then it is incomplete. How will we understand this? Let's do this example. And the example is something like this. Maybe you are standing on a platform and the platform is like this. Okay. And a train is coming towards you. Or maybe a train will come, but you're not sure if the train will come from this direction or from this direction. And you're not even sure that if it is coming at 50 kilometer per hour or maybe 100 kilometer per hour, you don't know this number. Okay, then maybe some other guy who's also standing there, you will ask him. Okay, so this is guy 1, this is guy 2, and the guy 1 asks ki from which direction from which direction will the train come? Just for precaution's sake, from which direction the train will come and how fast will it be? And how fast will it be? If you don't ask these two, both of the things, then obviously your life is in danger. Okay? So actually what you are asking is a number plus a direction. So again, actually you are asking is speed plus direction, and that is the velocity of the train. Okay? So if let's say I say that the train is coming at 100 kilometer per hour eh, towards right, towards right, then you have specified both of the things, and then you can say that I have specified the number as well as the direction. Acha, this number again here is also again called the how much. It tells me how much, and that is called the magnitude. Okay, I will write it here. By the way, this tells me about the velocity of the train. So please understand, if you don't specify both of the things, then you will not have a clear understanding of how the train is moving. If your primary question is how the train is moving, then you should understand how fast it is moving. You should also understand in which direction it is moving. Okay, so both the things, the direction and that number, has to be specified. Okay, and that is given by this velocity. Okay, so let me say in general, that number that I am talking about, the number is actually called the magnitude. And then you go towards the textbook definition. The textbook definition is a vector needs, so a scalar needs magnitude only for complete description. And what about the vector? The vector needs magnitude as well as direction. And direction, both. Okay, so I hope you get the understanding of what I'm talking about. Okay, so this is the definition and the intuition building of scalars and vectors. I hope the understanding is now towards you. So please understand again one thing, that the vectors are quantities which you have never seen, yani ki never dealt with. You have never talked about the direction, maybe in one dimension or anything like that, but not in two dimension and three dimension. So we will try to actually go back to our basics and try to differentiate between quantities and check which of them are scalars, which of them are vectors, and what kind of algebra do I need. So for scalars, if you remember, scalars are just described by numbers. And for numbers, you have very simple algebra. Yes, you have well-defined algebra, how to add them, how to subtract them, how to multiply them. All of that is unknown to you. But what about vectors? How to add them, how to subtract two vectors, and how to multiply two vectors, and what are the kinds of multiplication that we have to deal with. Okay, those things I will talk about in the next lectures. So I hope I meet you soon in those lectures.